Hi guys, Dr. J here, and in this video we're going to talk a little bit about sensitivity analysis for decision trees. Now Dr. Cares in the textbook makes the point that if you were to change some of the numbers that we looked at from our decision tree before, then the decision that you would make would possibly change because the expected payouts that you would have might be different. So if we look at the problem that we had before, we had this decision, clean or do not clean, and we worked out, based on using the rules of decision trees, that the expected payout of not cleaning up was approximately $21 million. And the expected payout is known for cleaning up, and that's about $15 million. So in this case, we said, well, definitely you would want to clean up because the expected payout is much less. Now, what if we were to change some of the numbers that we had? So for example, we have our uncertainty node here for sandbars versus sand channels. And remember we had said 50% for sandbars, 50% for sand channels. But also remember we had a big difference in the expected payout of each of those branches. So from our original problem that we worked out in the last video, we had a 50% chance of having sandbars or sand channels in the subsurface geology. And then we had an expected payout if we had bars of around $8 or $9 million, and an expected payout of around $33 million for the sand channels. What if we were to say now that the probability of having sandbars is 75%? Okay, so 75% chance that we have sandbars, and maybe that's established based on the geology. So maybe you have 4 geological experts and 3 of them say that you have sandbars in the subsurface and 1 of them says you have sand channels. So 25%, just going off the number of experts, 25% chance that you have channels, 75% that you have bars. Well, now if you look at these numbers, we may not have made the same decision as before, because now the expected payout is 75% times 8 million and only 25% times 33 million. So there's only a 25% chance, even if we do not clean up, if we have sandbars, the expected payout is only $8 million. And so this is a case where we need to do sensitivity analysis of our decision tree, just like we can do sensitivity analysis of our models to see which parameters are the most important. We need to do sensitivity analysis on these decision trees as well. And Dr. Cares gives an example in the book which you can look at. I'll reproduce that here. So what we're plotting is the expected payout for the 2 different options as a function of the probability assigned to that particular branch. So we have our graph here, and on the y-axis I'm going to put the cost of total cleanup, or not cleanup, the total cost, right? So the total cost of whichever decision that we make, and for cleaning up, that's 15 million. So if we say, let's take one of our parameters, let's take the cost of the lawsuit. So no matter what we do in terms of how much the lawsuit costs, the cost to clean up is always the same. The cost to clean up isn't dependent on any other branch in the decision tree because that's a fixed price. You have a fixed bid for doing the cleanup, $15 million, and that doesn't change regardless of how the geology changes or anything. It's just that cost. On the other hand, if your lawsuit changes, if the cost of your lawsuit changes, then the total expected payout of not cleaning up changes. So this is schematically what is shown in the textbook, but the idea is, right, below a certain cost of the lawsuit, it's actually a better decision, or I should say the total cost, below a certain threshold cost, below this vertical line, if the cost of the lawsuit is in this region, it's actually going to be more expensive to clean up on average. Again, the expected value of the cleanup is going to be more than the expected value of not cleaning up. And again, if there's a lawsuit, you'll end up paying $50 million. But the expected value is less, which means that you're not likely to have to pay more than the cost of the cleanup. On the other hand, if you're over here, anywhere in this range, which we are for the particular case that we looked at before, then the cost of the lawsuit leads to an expected payout for not cleaning up, which is greater up here than cleaning up. The cost of the lawsuit changing makes the decision different depending on how much it is, right? So if your cost of your lawsuit is $0, if you're not going to pay out any cost, then obviously you're not going to clean up because it won't cost you anything. On the other hand, if the cost of your lawsuit is a large amount of money, $100 million or more, you're definitely going to clean up because it's way too And notice that the probabilities of all these things doesn't change. It's not the probabilities of the lawsuit that's changing. Those are the same. It's the cost of the lawsuit which changes the expected payout that you're going to have for not cleaning up. So for a particular geological model, you might change the probabilities, look at the sensitivity to model parameters about whether or not you end up with contamination in your drinking water well. So you can do it both ways. You can actually vary the probabilities of various geological alternatives, and Dr. Kerr shows an example of that in the book. Whereas, for example, let's say that you change the probability of sandbars, as we said before, from 50% to 75%. That will affect your outcome. On the other hand, if you change just the cost of the lawsuit, not changing any probabilities, let's say you make your lawsuit $500 million instead of $50 million. Well, now the risk of having a $500 million lawsuit is so large that you would definitely want to clean up, regardless of the probability of having a lawsuit at all. On the other hand, if your lawsuit was only $1 million, you're probably going to take your chances in that case, because in that case, the cost of cleaning up is going to be much more than the cost of the lawsuit, even if you end up having the lawsuit. And so there's this trade-off, and we can use sensitivity analysis of our decision tree to determine what that trade-off is, and which parameters we might want to find out more about. So in our case, we might want to find out more about what a lawsuit would actually cost, or if there would be multiple lawsuits, and who would be involved, how much would it cost, how long would it take, things like that. We might want to get more information. On the other hand, for the sandbars versus sand channel, we might want more geologic information to find out which of those possibilities it is, and if we find out it's most likely that we have sandbars, that might change our decision. On the other hand, if we find out it's more likely we have sand channels, that would also affect the decision. Whether or not we ended up changing our decision from to clean up or not to clean up would depend on how those things turned out. Okay, so I am going to wrap up, and hopefully that was helpful thinking about decision analysis, and I will see you in the next video.